special guest. I'm really excited about this. We've been planning this for the last couple of weeks, but this is Sergeant Orrison, and he is with the Sheriff's Department. So he is one of 3 Reconstructionists, people, or at least people who are capable of doing accident reconstruction. So what he does is when there's a collision, he's able to go on scene and take lots of measurements, and because you know, every driver is going to have their own story of what happened, and so his job is to figure out what actually happened. So you guys can give full attention to Sergeant Orrison.
Good. All right. Ms. Weimer's right. There's always 3 stories at an accident or anything. It's one driver's story, the other driver's story, and then what really happened. Okay. There'll sometimes be variations, but that's my job, is to figure out which is which. Okay. Can we put that paper back up there that had our diagram on it? We'll go through some stuff that we do at accidents. I'll explain to you kind of how we come up with these things. You can't really see. This is actually supposed to be Plum Street is going up and down, okay, and that's 7th Street going across. All right, if you can see that. Yep, Plum and then 7th. Now these are not actual measurements. These were just measurements that we made up. Okay, so the vehicle that says V1, okay, that stands for Vehicle 1, was going south, and V2 was going west, and they collided in the intersection there. Where you see between the 2 V2s, it says 66 feet right here, and this represents how many feet of skid mark there is. Okay, so somebody locked up the brakes and left a skid mark. This one's got 123 feet here. Okay, so those are our first numbers that we're going to work with. Actually, when I get on the scene, I'll take either a big measuring tape or a wheel that rolls and measures how many feet and inches it is, and I'll roll the distance out so I can get how far that skid was. Then once I get those numbers, I have to figure out what we call F. Okay, when you're dealing with accidents and you're dealing with a lot of Newton's laws, you know, Newton's 3rd law, so on and so forth, you're dealing with friction and weight and how things move and everything. So one thing we use what's called a drag sled. Okay, and what a drag sled is, it's a piece of a tire. I have one out in my truck. It's kind of heavy though, but it's a tire that's cut across and then filled with concrete, and it's got a couple bolts in it, and I can hook a scale up to it. Okay, so I know if my drag sled weighs 35 pounds, okay, and I have to pull it. I have to get a scale on it, and I have to pull that drag sled across the ground and measure how much force it takes for me to move that. So I got 35 pounds pushing down, and I need to measure how much force it takes for me to drag that across the ground. Okay. Somebody got a calculator? All right, you ready?
Yep.
We're going to say we pulled it across the ground 10 times, okay, and we averaged 10 times out, and we got 23 was our average. 23 pounds was our average weight, okay? So what we're going to do is we're going to divide 23 by 35. What do you get?
0.657114.
Okay, 0.657.
Yeah.
So we say for this example, we'd say 0.66
Yeah.
would be what we would call F. Okay. In this particular accident that we're doing up here, we use 0.75, which is actually a very common one for a force on a paved road. Okay. So just so you understand how we got that number, this is how we did it. So my force is 0.75 for my F. Okay. So now the first thing I need to do after I figure this out is I need to go ahead and start figuring out, okay, how fast were these vehicles going when they collided? And there's some mathematical equations that you can do oh, thank you. There's some mathematical equations you can do that will tell you how fast a vehicle's going by how the minimum speed it was going to leave a skid mark that long, okay? So, if I need to know how the speed equals the square root of 30 times the distance times f, okay? The number 30 in here is a mathematical constant, okay? It's there. It's always there, okay? I don't know how else to explain a mathematical constant. D is our distance, which is for vehicle 1 was 123 feet, or vehicle 2 was 66 feet, okay? And we know our F is 0.75, okay? You got the calculator? All right, so take 30 times, let's figure for vehicle 1, 123 times, 0.75. Got all that added up?
Yep.
Where's that come to?
2,767.5.
And then do you know how to do square root on that? It is. About 52.61 miles per hour. Okay? So, by plugging all these numbers in, you know, and don't think that I am this genius person, okay? I didn't come up with this, somebody else did, they just told me what to put in here. So, that's how I come up with this. But in order to leave 123 feet of skid mark, I have to be going 52.61 miles per hour if I'm on a road that my F is 0.75, okay? Make sense? Okay? So now we can take and we can change this, and we can do for the other car, which is fairly simple to do because we just got to change the number here. This is 66. So now, when we add that together, that comes out to 1,485. And then that speed figures out to be 38.54 miles per hour. Okay? Not too fast. But if you're in a 30 mile, well, do we know what the speed limit is on Plum Street? Anybody? Anybody know? How old are you guys? 13, 14, somewhere in there? Well, you better start learning. 30, very good. Okay, and then on 7th Street? 30. It's a residential neighborhood, it's 30 mile an hour. So, he's still speeding, right? Okay, so the other one was really speeding, right? He was at 52.61 miles an hour. Okay, so, you gotta figure out how he gets speed, okay? By using some math, we figure out what speed is. Does everybody know what velocity is? No? Okay. Velocity is another measurement of it's kind of like speed, but instead of saying miles per hour, it gives you how many feet per second you're going, okay? So, speed equals, or I'm sorry, that's wrong. Velocity equals speed times 1.466. Okay? If you take anybody's speed times 1.466, that'll tell you how many feet per second they're going, okay? This is all good because you guys are going to get questions coming up in school that says like, train A left the station at 2, train B left the other station at 1:45, where'd they meet at? This is how you figure this stuff up, is these equations, okay? So, if we know our vehicle V1 was doing 52.61 miles an hour. And we gotta take that times 1.466. Then we know our velocity is gonna equal 77.13. It's very important that you always put these in here, feet per second, okay? That kind of clues everybody as to what it is you're talking about, feet per second versus miles per hour. You know, if I just put 77.13, somebody may think that's miles an hour, and I'm adding 20 miles or better to this car, okay? So it's important to do that. We can also do V equals speed times 1.466 for the 38.54 times 1.466. V equals 56.50 feet per second. All right, everybody see that? Okay, these are, when I'm figuring velocity here, I'm figuring that's their speed. They're not speeding up, they're not slowing down, okay? That's like they got their cruise control set. That's the speed they're going at. If their speed changes, if it's fluctuating, you know, it may not fluctuate very much, and we can still probably get away with using something like this, but if it's changing a lot, like they're slamming on the brakes and they're speeding up and everything, we'd have to do a whole different amount of figures, because we'd have to know where they hit the brakes, where they hit the accelerator, and so on and so forth. And the reason we want to change speed into velocity, okay, is there's a lot of formulas that you use for accident reconstruction that you have to know their velocity over their speed. That's the only way to figure them, okay? Now, let's say for whatever reason we want to know on that, where it says V1 on the top, and then go to the next V1 down, that's kind of in the middle, and then 123 feet. We want to know how long it took him to go from that, right where her index finger is kind of pointed at, to where her thumb is. We want to know how long it took that car to go that distance while he's because he's on the brakes, okay? He's sliding. What we need to figure out, for whatever reason, we need to know how much time that took. We can figure that one out too. And we will. Sometimes that can be important to us, you know. If we got, you know, there's a whole bunch of reasons. Could be phones, you know, we could have a time on a phone, and now we want to know. Yes, sir?
How would you figure out if one of the drivers passed away? How would you figure out what their story was?
Okay, so like they're driving down the road and they have a heart attack and die, and they wreck their car.
Yeah, or they just, they hit so hard they passed away.
Also would have a fatality accident.
Yeah.
Okay? Then I don't have the luxury of them telling me what happened and trying to piece out what's true and what's not true. I then have to go strictly math and base my opinion off of just what this shows. Okay? And you'll see, did they get any papers that had like the problem that we had on here?
They will. We're gonna do kind of a report together.
Okay.
And they will. They haven't gotten it yet, but.
Okay. So do I not want to give away the?
No, you're good to do it, because either way, we're just gonna be working through it together. So.
Okay.
You do.
The first instance that Ms. Reimer gave me for this was that she was trying to say that the V2 either stopped at the stop sign and went without looking to see if the truck was coming, or if what was it? They went too fast. I think, is that how it was?
I think it was that either they looked to see, hey, like these people are coming, but they're going way faster than the speed limit, so I can't tell how far away they actually are, or did they just not look at all and they just went? And
so that's what this was set up as okay, the vehicle 1 was going so fast that vehicle 2 didn't realize. I mean, they assume they're going 30 miles an hour because that's what the speed limit is, but they're doing 20 22 miles an hour over the speed limit, they close that distance a lot quicker. You'll find out here in just a little bit what actually did happen, okay? And that's how we'd have to do it if somebody passed away, you know. We'd have to just look at the math and see what happened, so. All right, how long it took to stop? We're trying to find out time, okay? So the T is going to signify time. We're going to take, for vehicle number 1, 123 miles an hour, we're going to take V1 minus V2 divided by A, okay? A is, it's an adjusted acceleration deceleration rate is what it's called, okay? And how you figure that is you have to take what is it? It's gravity A equals F times G, okay? Gravity is kind of hard to explain. Gravity is measured in feet per second per second. So what that means is if I'm moving at 5 feet per second, my first 1 second I'm going to move 5 feet, okay? My second, I'm going to move 10 feet, okay? So in 2 seconds, I've moved 15 feet. Does that make sense? It's kind of doubling, okay? That's kind of how gravity works. The numerical assignment for gravity is 32.2, okay? I think I'm right. So we're going to take 32.2 times our F, which is 0.75, and that is going to equal, what did I say it was, 20, so A equals 24.15, okay? So remember, we're taking our F times gravity, and we're getting our A, which is our adjusted acceleration deceleration rate. Okay. So velocity, we go back to that. For the first car, the V1. V1 is going to be the highest velocity we have. Okay, so the fastest that we can show that it was going feet per second was 77.13 feet per second. Now we're going to subtract the lowest velocity we know it was going. Anybody got an idea what that is? How fast are you going when you stop? Like you hit something, right at the end you stop, right? How fast are you going when you stop? 0. Okay. So our V2 is 0. Okay. So we're knowing he's changed from going 77.13 miles an hour to going 0, or 77.13 feet per second to going 0 feet per second. Okay. Now we're going to take that and we're going to divide that by our A, 24.15. That's going to give us 3.19, and we're measuring in time, so we know we're at seconds. Okay, so to slide that 123 feet from where he slammed on the brakes, locked him up, and slid to where he hit that car, 3.19 seconds. Okay, everybody got that? All right, we can do it for the other car, which is going to be the same thing because they were going 56.5 feet per second, slammed on the brakes, and they came to a stop. Okay, so our A is the same, 24.15, but we're changing our 77.13 right here to the 56.50 for the other car, and it ends up being 2.34 seconds. Okay? Everybody understand that? Okay. Everybody has what's called a reaction time, okay? Does anybody have, do you have any clue what reaction time is?
When they did the break.
That's exactly it. I throw a marker at you, it's how long it's gonna take you for your brain to realize, hey, that marker's coming at me, and try to do something, okay? That's reaction time. The average reaction time for people, for human beings, is 0.25 seconds, okay? You're a little quicker. You guys are actually in the quickest area of your life right now. At your age, you react quicker than I do, you know. And the sad part is I'm in the age right now that I'm at the slowest reaction time, and here in about 5 years, I actually speed up. For some reason, I have no idea why, but that's the averages. So we know, for whatever reason, we need to find out where these people were when they noticed each other, you know, and we can do that. We can do that because we know when he slammed on the brakes, right? Because we get those black lines that tell us, hey, we hit the brakes right here, right? Okay, and now we know how fast we were going, either 52.61 miles an hour or 77.13 feet per second. Okay, and in order to figure, this is called time distance. Okay, we're looking for how far he traveled. Okay, so we know we're looking for distance, right? We know his velocity was 77.13 feet per second. And how much time are we going to use? What's the reaction time? 0.25, right. So we're going to take that times 0.25. Okay. So you have, we're looking for distance. We know velocity. We know time. If you multiply velocity and time, that gives you distance. Okay. So we'll multiply those two together, and it comes out with distance equals 19.28 feet. So in a quarter of a second, okay, we know this vehicle in a quarter of a second traveled 19.28 feet. Okay, and now if you look on the diagram there, the top two V1s, it says 19.28 feet, and it says 0.25 seconds. So that the 123 feet from the bottom V1 up to the second V1, that's how much he slid. And then when he realized that there was a car coming, that he was probably going to get in a wreck, I backed him up to show how far he traveled after he realized that happened. So that's where he was when he saw the car. The second V1 is where he was when he hit the brakes, and the third V1 is where he was when he hit the car. Okay. Go.
Wait, so it's the same car?
Yeah, these are.
Oh, okay.
They're all three of those represent the same vehicle.
Okay, I was thinking there was like a couple cars. Like, whoa.
Can we shrink it down just a hair so I can see the other car too?
Yes.
There you go.
Okay.
Okay. Vehicle 2, vehicle 2, vehicle 2. Okay. Vehicle 1, vehicle 1, vehicle 1. This is our point of impact where they collided. This is just to show that he's 123 feet back, and then this is here is where I showed it 19.28 feet. That's what it was in a quarter of a second, 0.25 seconds. Okay, so that's how far back he was. That's why I wrote he saw the car here. This one's kind of crazy. Does anybody know what this is? Stop sign. Okay, and that's what was giving me a little bit of fits on this one, you know, because I'm sitting here trying to think, okay, what did this person see? Did they see the truck?
No.
Or did they see the stop sign? You know, I wasn't sure which it is. But you'll find out here in a minute when we start figuring up, okay, did this car stop at the stop sign? All right. And then I think what they were looking at was the truck. They probably didn't even know the stop sign was there, but we'll find out. Okay, in order to figure out if the car stopped at the stop sign, okay, we still have to do some time distance stuff, but what we have to figure out is the car capable of making it to 38.54 miles an hour? And because it left 66 feet of skid, okay, so that's, we know it was that. So from there, can that car actually make it to 38.54 miles an hour in the amount of distance that it took before he got to the crash site, okay? So in order to do this, we're looking for a distance again, okay, because that's what we're asking. Can the car do it? Can it? And how much distance does it take for that car to get to that speed is what we're looking at. So this one is going to be speed squared over 30 times f. Okay? So our speed of this car is 38.54 miles per hour, right? 38.54 squared over 30 times 0.75. All right, Mr. Calculate Man. 38.54 squared. Do you know what square is on there?
Yeah, I'm looking for it.
Okay.
Okay, got it.
Got it?
Yep.
Okay, what'd you come up with?
1,485. 3.3.
1,485 what?
0.33.
0.33?
Yeah.
That's exactly what I got. Good job. And 30 times 0.75 should come up to 22.5.
27 minutes. Oh, 30. Yep.
Oh, very good. All right. Now take 1,485.33 and divide that by 22.5.
64.81.
What did you do different than I did?
Wait, were you supposed to divide it? Right?
Yeah.
Yeah, 1,485.33 divided by 22.5.
Yeah.
So you got 64?
Yeah.
All right.
Divided by. Oh, it changed. 66.01.
That's what I got.
I don't know what I did wrong that time.
Okay. In my story for this accident, I said that the driver of vehicle 2 told me that they stopped at the stop sign, but those were not skid marks I saw from them stopping. Those were acceleration marks. You know, they're burning out. Okay, those were black marks that he left from spinning his tires. Sometimes we'll have people who tell us stuff like that. You know, complete opposite. They see a black mark and they figure, these guys are idiots, these cops, they don't know nothing. They can't tell if that's I've slammed on the brakes or I've spinning my tires. And he left 66 feet of skid. So in order for this car, vehicle 2, can get up to 38.54 miles an hour in 66.01 feet. Okay, that's for us to have 66 feet of skid in this. You know, that does add some. Okay, what he's saying could be probable. Okay, but now is when we're have to. I'm done with these. Now is when we have to go to what we actually see on the scene here. Okay. Now we get a little bit more information here, okay? Plum Street, okay? From this curb to this curb is 31 feet, right? Okay? from the center line to this curb is 16 feet. How many feet does that leave us over here? 15 maybe? 15? Okay. Now, and I didn't draw a measurement out for this, but if you look, we're close to center. Okay? So what's 15 plus 8? 23. Okay. How many feet is it to the stop sign? 12. So 23 and 12? 35. So they couldn't have stopped at the stop sign. Okay? Because in order to get to 38.54 miles an hour, they need 66 feet. And they're 35 feet from the stop sign. Does that make sense? Okay. So in this accident, I could say vehicle 1 was speeding, vehicle 2 was speeding. He was going 8.54 miles an hour over the speed limit, but vehicle 2 did not stop at the stop sign either. Okay, so that's kind of how we figure out accidents. And then this is just a real basic, simple, easy one. So, anybody got any questions? Yes, sir?
So, like, how would you measure if they got in a high-speed chase? Like,
You mean
crash.
if they got in a crash like we were chasing them and they got in a crash?
Yeah, like, because this summer, like, some cop chased this guy through my neighborhood. He was going, and he went through my neighbor's, like, rock garden, drove through that, and crashed into their cars, and they're, like, measuring something, because I think he hit the brakes and tried to turn the corner, but then he just crashed through.
Okay, well, that's a good question. Yeah. So we're driving on the road, right? We're running from the police. Is your okay? Here's the street.
He lived on the corner, and it was like, you know, them rock gardens that.
Like people have like
The corner rock gardens. Yeah, like
kind of like that
yeah.
kind of thing. Okay. Okay. So this is the street. Okay. When I show up, you know, I told you the one thing that I do is I go and I measure F by using the drag sled, right? Okay. So the F on this road might be, since it's a paved road, might be 0.75. Okay? This is somebody's yard, okay, that they drove through, and they're sliding, whatever. You know, this might be a 0.49. Okay? If this is a rock garden and they crashed skidding over it, I'd have to take a drag sled measure over it also. You know, this might come up to a, who knows, a 0.62. Okay? So now what I have to do is if I have skid marks, like so, that run across all of this, I then have to measure how much skid is here, and how much skid is here, and how much is here, and how much is here. You know, so I have to measure each one of those. Then I have to go ahead and figure speed like we did before. You know, speed equals the square root of 30 times distance times f, and I have to figure that for each one of those. Okay. Then there's another formula that is called combined speed. I'd have to look it up. But then I start adding this speed to this speed, and then figure out what this is, and then add this one. Then figure out what this one is, and add it. And then figure out this big one and add it. And by the time I'm done, I'll have a speed that the vehicle would have had to have gone to go across all of it. Does that kind of answer your question?
Well, yeah. Except for if you like hit the rock garden and then like made like black marks through the grass and hit one car and slammed it into it.
Yeah, there's a whole lot going on there, you know, and I'll be the first one to admit that there's gonna be times in accidents where I'm gonna call the person who taught me and said, hey, what do I do here, you know? But that's how you figure speed for that, you know, and the rest of it's just measuring and then figuring out what we want to do, you know. All these all these time distance equations, you know, are still going to work for those. You may have to do more than one, you know, but you can get there. Anybody else questions? Yeah. How much time did I take? Yes, sir.
Why did they have a stop sign over there? Because usually don't they have like a stop sign like every corner? Like they didn't have one on that street, they haven't had one over there. Or is it for both of them?
Well, Plum goes that way, and a lot of times Plum is just a all the way through street where there are little side streets that come, and these guys have stop signs, but these guys don't.
Yeah.
Yeah.
Sometimes there are intersections that all four have a stop sign, but a lot of times they're not. Okay? Yes?
How long does the normal process take after a wreck? How long does it take to do all this?
It depends on the how big of the wreck was, how, you know, how much stuff went on, how many surfaces they went over. I have actually reconstructed a wreck that took, for me to sit down and put all the calculations in and figure everything out, and type a report and submit my report, took me about 8 days. 8 days worth, you know. I mean, it's not like I get to sit at a computer, you know, I work 12 hours a day. That's what our shifts are. It's not like I get to sit at the computer for all 12 hours and do it. I still have other stuff I gotta go do, so it's intermittent times throughout that, but probably 8 days. I've seen some that take weeks, you know, to do pretty big ones, so. This one, like I said, was really simple. It took me a couple hours last night to sit down and figure this out.
What would you do if there was multiple cars? Like, you said there's only two for that one. What would you do if there's like a ton of cars, like you don't see in the middle?
Well, that's a good question, because now we get into actually what a traffic accident is. Okay, if you have two cars that hit each other and a third car that comes in and hits, okay, that could be one accident. It could be two accidents. It depends. If the first two cars that hit each other have come to a complete stop, okay, and then another car hits one of them, that now becomes two accidents. Once everything stops, even for a split second, that accident's over, even though they're still in the road, okay? So then you just have to figure out where they were when the first two crashed, and then where they were when the next one came in, and just keep building on that. That's why I feel really bad for some of these officers who work in places like Seattle or someplace, you know, where they get on an interstate where there are tens of thousands of cars going across the road a day, and they have what's called a pile up. You know, you might have 160 cars all pile into each other in the fog or something. I would hate to have to work that. That would be a mess. So that's one that would take weeks to reconstruct. Anybody else? Go ahead.
What do you do if it's like a bike accident, like they hit with a bike or something, like, I don't know.
A
Like,
bicycle
yeah,
or like a motorcycle?
Bike, normal bike, I don't
Okay.
know. Anything?
There. A bike is going to be a little different, like you're pedaling, okay? Because it's going to have different. I mean, it's still considered a motor vehicle. It's still a traffic unit. So you're going to kind of work it the same, you know. But in a lot of instances in that, you know, I'm going to have to start measuring how far a person slid across the road or got thrown or whatever, you know. So it's going to be a little different for that. So, but it can still be done. You know, I went to a class for accidents, and we were fortunate enough that a local record company who had cars that they'd repossessed, they brought those out and let us actually crash them. And they would drive a car, and they put up a dummy, stood a dummy up, had a hat and glasses and shoes and everything on. Every time the dummy got hit, the shoes came off, the hat fell within 3 feet of where the dummy was standing. The sunglasses would go who knows where, but the dummy might go 40 feet down the road. But it is that's just what they told us, you know. It's not an exact science where that hat's going to land. But the hat, every time we've ever done it, the hat's landed within 3 feet of where the person was standing. So who knows? Anybody else?
Okay, can we give Sergeant Orrison a hand? Thank you, Mr. Thomas.
It's like an airplane crashing into each other.
I call the highway patrol because we don't work airplane wrecks. Highway patrol does.
All right.